219. Camera. I just don't know whether to change it to cosine or
No, don't.
sine.
As long as they're the same function, don't, because then all you gotta do is factor out there.
Oh,
So now, where on your graph is tan x equal to 0, and where on your graph is tan x equal to -1?
I made it more complicated than it had to be.
Yeah, you can use sine and cos for that, but I wouldn't. As long as I have the same trig function, work with it,
Okay.
okay? Only change if you've got like multiple like sines and coses and they're all over the board,
Okay.
okay? Alright, Georg?
3B on 209.
Need a common denominator for it?
Yeah, like, so I multiply 1 plus cos x by 1 minus cos x.
Yep.
Okay.
So basically what you have then is on the bottom, you have 1 minus cos x, 1 plus cos x, right?
Yeah.
So what do you multiply this guy by? 1 plus cos x up here. And over here you have 1 minus cos x. Right?
Yeah.
So far so good?
Mhm.
So now I've got 1 plus cos x minus 1 plus cos x. And on the bottom right now, I have 1 minus cos squared x. So far you follow me?
Yeah.
Okay? 1 subtract 1 is 0. That gives me 2 cos x here. And on the bottom, what is 1 minus cos squared x?
Oh, the difference is squared. Or, no, oh. Not sure.
What's your very first identity?
Oh, yeah, okay. Sine squared x.
Sine squared x. So I could write it like this. I didn't even ask what the question looks like. To express a rational expression as a single term. So
Yeah.
I'm close to what I need here, okay?
Mhm.
But I don't know how I get it to a single term.
Well, if you do,
Like it could be, like cos over sine is going to give me tan. Well, that's probably what they want. They probably want this, 2, cotan. Cotan x cosecant x. That would be as a single term. 1 cos over sine gives me cotan x. Leaves me with 1 over sine,
Okay.
which is cosecant x. So I guess that's what they would want there.
Okay.
Okay? Yeah, no problem. All right, anybody else?
Page 219, 4D.
Okay. So right now I have a double angle on this side, and I have a single angle on that side. So we want to make them the same. So let's make them both singles. So I need to change cos 2x. So which one of the identities you want to use for cos 2x?
1 subtract 2 sine squared x.
Very good. 1 subtract 2 sine squared x equals 2 sine squared x. So far so good? Okay, I'm going to add the 2 sine squared x over to there. So that gives me 1 plus 4 sine squared x. You okay? Alright. Sine squared by itself. What are you going to do? What do I get rid of the 4?
Just divide 4 by 4.
So I've got 1/4 equals sine squared x. Oh, I know what your issue is going to be here, right? Okay, so I've got that so far, right? Now what do I get sine by itself? How do I get rid of the squared value?
Square root the other side.
So what is the square root of a quarter? Plus minus a half. So now you go around your circle. Where does sine x equal a half and negative a half? Yeah, which is what, radians?
Pi over 6.
next one.
Five, five, six,
Very good, keep going.
and 7, 5, 6.
There we go. And
11, 5, 6.
good job. There's your answer. Okay, so where did we lose you? At the top here?
I just wasn't sure if you could subtract, or if you could add the two signs together. I wasn't sure
Yes.
if the one
Oh,
had to
okay.
stay with it.
So going from here to here?
Yeah.
Yeah, okay, yeah, you can. Yeah, Jake?
Could you subtract the 1 over 2 with the new difference of squares?
Yes, you could, absolutely. That's actually what the book does. The book does that, so I would get 0 equals 4 sine squared x minus 1. 0 is equal to 2 sine x minus 1. 2 sine x plus 1, just like that. That's fine. In fact, I'd encourage you to do that. So sine x is equal to, again, plus minus 1 over 2. So that works too. Yeah, that's very good. Okay? Alright, Phyllis.
Just the plus minus, for the other ones, we didn't do that, but why do we do it for these ones then?
Because you're square rooting it.
Oh, okay, so we did the whole thing.
Yeah, so, but if you look at it the way I did it this way, you can see why I do that.
Yeah,
Because if I do difference of squares, I get x equals a half, or sine x equals negative a half. So when I square root, I need to know, remember to do that. Okay, this mistake gets made lots when you take the square root and you forget to do the negatives. When you take the square root, you're gonna have 4 values always. Okay, unless the value's 1. All right, anybody else today?
I have one from further back again.
Sure.
11B on 204. Did you do this?
I've not done it yet, okay. Okay, you're gonna have to, never mind, I'll help myself here. I was gonna say, I have to help myself. Okay, so I've got cos of pi over 4 subtract x, right? So I'm going straight to my identities here, okay?
Yeah.
So I got cos pi over 4, cos x, plus sine pi over 4, sine x. That's times 1 over cos pi over 4. I think.
Yeah.
Okay, so I'm just gonna start with this side.
Okay.
Okay, just that. Okay, cos of pi over 4, root 2 over 2, cos x, plus root 2 over 2, sine x, times 1 over, so this would be 1 over root 2 over 2,
Yeah.
which would be 2 over root 2. And flip it. Okay?
Mhm.
When I multiply it through, I'm going to be left with that.
Okay.
Okay, so far?
Yeah, that makes sense.
Okay. Now you work the other side. Do the same thing with the sine. So I'm just going to do it below and then I'll bring it all together just because of room. So I'm going to have sine pi over 4 cos x minus sine x cos pi over 4. All that's going to be times 1 over sine pi over 4. Okay, so again I get root 2 over 2 cos x minus sine x times root 2 over 2 times 2 over root 2. So I multiply the 2 over root 2 through the brackets, I end up with cos x minus sine x.
Yeah.
So now,
And that side is,
so it's a subtract in between them, so I have cos x plus sine x minus cos x plus sine x. I gotta distribute through these brackets here, that negative. Okay, I'm sorry I'm going all over the board, can you follow what I'm doing?
Fine, yeah.
Okay, they cancel, so what am I left with? There you go.
Thank you.
Okay, no problem. So basically, all I'm doing is just writing out my identity, and then simplifying until it does that. It's not a question that I'd be too worried about.
Okay.
Jeffrey, go ahead.
Can you number 4C on 210? Is that part of the
Alright, you say you have part of it done?
Yeah.
I'm about to find out. Cos x minus sine x all squared, right?
What page?
So that is cos squared x minus 2 sine x cos x plus sine squared x equals. Did you get that far?
Yeah.
Awesome.
And then, can you do
And then I got just a sec, Jeffrey. 1, 2 sine x cos x.
Yeah, okay, that's fine.
Okay? You that far?
Yeah.
I want to show you something. Okay, what am I doing here? Am I proving?
Yeah, it's proving each
Sorry, I didn't have to do all that. Okay, but let's do it anyways. Okay, I was just looking back at my notes I made last year. I just did this afternoon. And I was looking at the notes I made from last year on one of the things that I should point out to you. And one of the things in this section is to actually work a little bit more often on both sides of the proofs on trig. Just according to when I marked the exam last year, I recognized and I said, you know what, maybe we should be working both sides, it might make it a little easier. So just looking at this here, I have that, right? Well, what else do you notice about this guy?
Cos squared x plus sine squared x is 1.
Is 1, that's right. So I got 1 minus 2 sine x cos x equals your right hand side. Okay, cos squared plus sine squared is 1.
I didn't know you could do it over the
Why not? Okay,
distance.
so what, alright, and I get that. I 100% agree. That's how they throw you off, right? They put a term in between. But why couldn't I just write it like this?
Yeah, I guess that doesn't make sense because it's all in one. It can be.
If I wrote it like that, do you think you would have seen it?
Yeah, that, I can just like, it makes sense.
Yeah. So that is the one thing that they will throw at you a lot. Very often they'll throw that at you to see if you can pick up when there's a term in between. A cos squared and sine squared equal 1. Okay? Anybody else today? Okay.